In this video, let's consider the famous birthday problem, just to get some practice of the combinatorial argument, n choose k, and the permutations that we just learned in the previous video. So what is the birthday problem? Let's consider the following. There are 80 students in our class, approximately. What is the probability that at least 2 of you have the same birthday? Well, you can guess without calculation what that might be. And the answer might or might not surprise you. But let's do the calculation and see what that probability is. So in order to do the calculation, we first represent this in a mathematical way. There are 80 of you. Let's say the birthday of each of you is represented by a random variable, say x1, x2, to x80. These are the 80 birthdays of the 80 students in our class. And let's ignore February 29th. Let's suppose that nobody has birthday February 29th. Then these 80 random variables are random variables that takes values in the set 1, 2, 3 to 365. And suppose that each random variable, the birthday of each one of them, is taken from these 365 numbers with equal probability. This may or may not be true because some people might argue that people who are born in July are smarter, therefore they go to a graduate program with higher probability. Let's just ignore that and say that the birthday of each one of them are taken from these 365 days with equal probability. And let's say there are no twins among you guys. So no twins, meaning that these x1, x2, x80 are independent. Now, given this setup, how many equally likely states there are? Well, for each of you, there are 365 different possible birthdays. And there are 80 of you. So therefore, there are 365 to the power 80 number of possible outcomes. And all of these possible outcomes, all of these possible states have equal probability. There is no reason to believe that any state is more likely than the others. 365 to the power 80 number of equally likely states, or equally likely possible combination of values for these 80 random variables. Among these equally likely states, let's calculate the number of them in which none of you share birthday. How many of the states are such that 9 of you share birthday? Well, you can state this in a different way. If 9 of you share any birthday, if 9 of you share birthday, that means the 80 of you have 80 different birthdays. And these 80 different birthdays are chosen from these 365 days of the year. How many possibilities are there? Well, what you are doing is actually choosing 80 numbers from this 365 numbers and put in 80 boxes. Because suppose each of you have a box, and God picks 80 numbers for your birthday and put them in your box, and that's your birthday. So the number of ways to do that is actually 300 it can be obtained in two different ways. One is to fill each of your boxes sequentially. That would give us 365 times 364 times 365 minus 80 plus 1. So these are the number of possible states in which none of you share birthday. That's one way to calculate that. The other way, as we have learned, is to first choose the k possible birthdays and choose k. In this case, n is 365. Choose k, 80 birthdays, and then distribute these 80 birthdays to the 80 of you. Then that's times 80 factorial. And these two numbers are exactly the same. And what is the probability that none share a birthday? And that would be the number of states consistent with this statement divided by the number of all possible states, consistent or not consistent with the statement. So you can do the calculation, of course, not by hand, but by computer. You can find that this number is actually incredibly small, is approximately 0.0001. So it's very likely that at least two of them share a birthday.